The panelists will address the challenges of digitalization, open software, the interoperability of technologies and digital twins, and explore the potential applicability of smart technologies developed in EU-funded projects in current and future PCIs. I welcome to the stage our speakers. Frank Amand, CTO at Operato, world-leading provider of grid enhancement technology. Hello and welcome, Frank. We have Santiago Gallego Amores, regulation manager for Europe at Iberdrola. Joining us next is Karol Kósa, Executive Director of the Electricity System Development Section at SEPS. I'm welcoming to the stage Jennifer Mertens, Head of Distribution Network Technology at Bayernwerk AG. Ugo Stecchi, Project Manager and Researcher at ETRA. And Ádám Tóth, Head of Network Innovation and Funding Management at E.ON. It's always great when panelists are coming from all over the place. Such a nice dynamic. Okay, we have a great panel, and moderating this panel is István Vokony from Budapest University of Technology and Economics. He leads the Department of Electric Power Engineering. As a researcher, István Vokony is deeply engaged with the cutting edge of digitalization and smart technologies. So just a perfect match for today's topic. Here we go.
This was the first test how to involve new technologies into the daily business. That will be the most important part of our panel. As you can hear me already, let me share you a short story. I arrived here this morning by car and running on the highway. I saw some technicians, I guess from DSO colleagues, working on some maintenance, cable maintenance, I guess. With heavy rain, they were very muddy and everything else, and it came into my mind that we will discuss about smart technologies and brand new solutions and long-term projects and strategies, what they recognize from this part. So I hope in 30 minutes you will have some answer or the answer, but yeah, it will depend on the discussion and it will depend on you. So I will ask our technician colleagues to put on the slide on the screen. So it will be the second test of the technology for today, because we prepared some questions to involve you into this dynamic approach and discussion. So I hope we will see a QR code on the screen, but if not, until then we can jump into the main topic. And Ádám, if you are ready, I would start with you. As we recognized from the intro and the previous videos, there are some brand new technology involving into PCI activities as well. And a couple of years ago, when I was a PhD student, a couple more, but never mind, there were always buzzwords. On that time, smart was the greatest buzzword than everything else. And since then, it's outdated. Today, the digital twins and other buzzwords are the most sexiest one. Is if you would like to prepare a paper, what is your idea? What is your expectation? Is it possible to bring those kind of technologies into real life? And the other part is, how is it possible to differentiate, for example, a large PCI project comparing to other horizon activities?
Thank you, István, and I just wanted to say that I'm grateful to be here. And to answer the question about digital twin and how we can start that, we started by defining it. So what is digital twin and where DSO is in this status right now? Digital twin is data-driven, real-time visualization method. And for the energy system itself, can be a substation, the grid itself. So this is where digital twin can be imagined, and already there is so many materials about it. But are we there yet in the present, or we will be there in 3 years? And I would say, as some of you might think, we are much closer than it is imagined. So if you know how the system operator works, they are having real-time data. If you know how long-term planning works, they need modeling data, a lot of data sets in order to build up their models in digital environments. It's not digital twin now, but it's something, a part of it, which can be used in order to our day-to-day business operation to feel closer to use digital twins. And how is it connected to the funded projects, self-funded or Horizon-funded projects? If I see, for example, Danube Grid, we have several substations which is fully remotely controlled. We have 1,500 fault sensors and switches installed. We also have another 2,000 smart devices which will be developed and installed within 1 year for medium voltage transformers. So, and also there is also 170 kilometers of OPGV, so optical lines, which improves the data quality and also the data transmission. And I think it's a really important message that this is how contributes towards digital twins, which is not there yet, but this is always needed to improve as a DSO. But just to be clear, there is like, if you think about business as operation, business as usual, we have 3 main challenges I would like to highlight. The one is data quality. Has to be improved, I can say. The other one, which we usually forget, is the cost of data and the cost of data transmission. I'm a high voltage electrical engineer, so it's not my field. I'm always surprised by the price, and it's good learning. And third is availability. So it has to be available. The grid is resilience. It's built to be resilience, and data has to be resilience as we get it in order to be used as for digital twin, which is a really high-tech solution in my view. And that's why we need also the Horizon Europe projects. And I would like to mention Twin.EU, where also we as the Hungarian DSO is part of it. It's 75 consortium members from 15 different countries in order to improve TSO, DSO and cross-border collaboration towards the European Twin.EU to create a digital grid. So also you can find a very nice article from EDSO about it. I really recommend to read it because it summarizes where it goes. And why we need it. It's, if I remember well, 3 years project. We need time to gain trust towards toward digital twins. And that's how Horizon Europe project can came into the picture. So as from one side, like a SEPS project, it's much closer to business as usual operation and creates the basics, the core. Like this kind of Horizon Europe project can give us the time to gain trust and real experience to like explain ourselves how to use it in the future. So that's my view, István. Thank you.
Thank you, Ádám. And you mentioned the digital network and digital grid, and I would like to state the next one to Karol regarding digitalization and bringing the network development into daily business. So what do you think? A fully digitalized grid operation, it's a possibility, it's a must? Or do you see the most progressive areas where it's really a daily business or daily operation, business as usual, using that kind of technologies? And can you identify such areas where in 5, 10, 20 years term, we shouldn't go into a highly digitalized operation? What is your expectation?
Yeah, thank you for this question. I think what to say this to this topic, because it's really difficult to say something smart because everything has been said. before, but I would like to say one thing. Digitalization doesn't mean that it can solve everything. At the beginning, we have to go step by step. This is very important, but we have to say also that what the digitalization mean, because on the TSO level, it's not a very new term, because we can say, at least in Slovakia, we have digitalized the asset almost as the whole. The big problem is maybe on the DSO level, because they are not on that track so far, but they are moving very quickly forward, and I think that this will be essential thing, a must for the future. I mean, without the digitalization, we cannot move, we cannot fulfill the very ambitious plan for the future. The one is a transition, energy transition. We also have to keep in mind that we have here another topic we have to deal with, and it's an aging asset. It has been said and mentioned by Ona. This is a very big challenge, at least for the TSO, but I can say that also for the DSO environment. So we are moving step by step in that way. We try to digitalize the whole asset, at least in the condition of Slovakia. We are not far away from that. And I can say that the infrastructure will be prepared. Now it's just on our shoulders, how it will be used, what kind of artificial intelligence we can use, how to make this infrastructure more efficient, better utilized, because I think that this is the main problem, how to use the existing infrastructure as much as possible. And what we can expect for the future, but now I'm not saying just about the TSO, but also for the DSOs, that we will have to continue in this way of moving forward, because we know that what are our duties, that were said a lot about the duties, about the regulatory framework, about the expectation from the infrastructure, how we can serve for the grid users. And this is not an easy task. We have to go step by step. And we realized in the last 2, maybe 4 years that without smart technology, we are not able to keep the pace. Because the traditional tools are not sufficient to keep up with the very quick changes in the electricity system. At least in the Slovakia condition, we noticed that the situation changes from 1 hour to another very dramatically and rapidly. And so far, we can say that we are not so prepared for these changes. Everybody is saying about the grid that has to be resilient, has to be flexible. It sounds like a cliches, but without these 2 terms is a lot of money. Of course, a lot of efforts how to reach this ambitious. We have some idea how to fulfill these goals. There is also a very good tool how to help us to really fulfill this goal is PCI status, and of course then self-funding. We used this opportunity in the past, and we are using this opportunity, and we would like to use it also for the future, because it can help us at least to make these projects that are not so known in the environment. And even our staff has a problem with smart technology project, because we are just looking in the future how to use them, how to operate them, what can be the benefit, how we can explain to the grid users that we will need this type of projects. And for that purpose, also the PCI status can help us very well. And it was already mentioned that where we are facing a problem is permitting. Permitting is a real problem because we are not really able to fulfill our plans on time, and we would like to do and make the process more flexible, more efficient. And in conditional Slovak Republic, we have two status of investment. One is an important investment, and the second one is a strategic investment that help us to fulfill our plans on time as far as the permitting process is concerned. So just to wrap up all these things, I have to say that we are moving somewhere. Now I'm not really able to say where. Whether it is a good way, whether we are patient or we should be more patient, because we would like to change the things from one day to another. It's not possible, at least not in the energy sector. That's why I just want to say that we need to be a bit patient and then go from step to step. Of course, digitalisation will help us. Will help us. Now I cannot say how, but I am convinced that we will reach another milestone in the energy transition, and then I think that we can keep and fulfill our goals. Because also the pace is very important. If we will not patient enough, I think that we can do not always a good decision, and especially as far as the smart technology is concerned, it was also said before that this is not just a simple comparison of the cost, but also the benefit is very important.
Thank you, Karol. If I won't be mad, I would say that you got me. I already see the reasoning and everything else in some aspects, in some use cases and in some technologies. So I got the what. But Ugo, please help me. I would like to see the how. So if we are talking about bringing into business as usual or daily operation, such kind of technology, solution, processes, anything what you already introduced, how is it possible on TSO or TSO and on end customer level? Because at the end of the day, it's always about the end customer we are talking about. How?
Thanks, István. First of all, I would like to say that I can report my experience, especially from Horizon funded project, where we have a good presence there, and we are involved in several projects with TSO, DSO, and customers as well. Well, bringing the results, the outcome of the innovation then to the real life, it's always not that easy as it could seem. The interaction with the stakeholder, with the pilots, it's something that it's critical, and you have to go through that before the innovation, the result, the outcome, the tangible result will arrive at the final users. And for the final user, I don't mean only the final customers, final users in general, also business users. In R2D2 experience, the project that I'm coordinating right now, the experience that we have is that you have to straight focus on the actual functionality that you want to innovate. If you want to arrive to something concrete at the end of the project, and something that can have some expectation to arrive to real life at the end, after the end of the project. In this sense, it is crucial the contribution of the stakeholders within the project. and within the development of the tools and the services that you are going to produce along the lifetime of your project. So the involvement of the stakeholders and the final user is fundamental to obtain at the end of the day, at the end of the project, something that can have realistic opportunities to be transferred to the real life.
Sorry, and the interest is only money, or?
No, of course no. The interest is not only money. The interest is having a product that at the end of the day is really useful from the business operation or the business process or the operational process of the final users. Having involved the final user during the definition and the development of the service or the tool, it's something that we had experienced that it's very turnover at the end of the project, and it would like that the results will likely be transferred in a real opportunity to the market. This is also something that we discussed in similar forum in the past, also with Santiago months ago, and at least this is our experience. For example, Electrolubiana also is a partner of our 2D project, and in a presentation from in the first panel we heard before today, representative from Electrolubiana Juritzurk also focus on the specific functionality. Unless we are talking about, of course, strategic innovation at European level, like digital twin or like data spaces that were mentioned at the beginning from DG representative early this morning, staying focused on the specific, I would call it incremental innovation. It's what that can assure you to arrive at a successful result. In this perspective, conversation and experience that we have with the stakeholders within our project had identified also another fundamental parameter, that is the timing to obtain a minimum viable product at the end of the project. Whatever it stays within, I would say, 2 years after the end of the project, it will have a good probability then to arrive to market. The focus of this session, I appreciate very much the focus of this session that you share before, because you want to stay also in the previous conversation with Uros, we want to stay focused in 1 to 3 years after the project to arrive in real life. I would say maximum 2 years in this sense. Otherwise, cost will increase too much because it means that you need to revalidate a lot of things before arriving in a real life, but also the market will evolve. So your innovation, your research, maybe it's not up to date as you expect it to be. And the competitors are running and they are not waiting for you.
Thank you, and it's a really nice idea to go further regarding the market. And I know that the energy crisis, everything else it's quite bad and a sad story. But I see the how should I say, positive part of that the awareness on the energy sector and how to use and utilize the energy is getting higher and higher, and that I think and at least it can be a positive part. But where are we now? How is it possible to involve actively the stakeholders? You mentioned the final user, not definitely the customer, but from flexibility market point of view. Santiago, what is your experience? How can we involve actively the let's say the final user?
Hello, thank you very much for inviting me to this conference. We have heard about your question in the previous panel. I think this is the right question, and we have to address it. I was going to say that from our perspective, it's the perspective of my perspective of a DSO participating in European funded projects, but also as operating in 4 countries. So we have the perspective of with different geographies. We are operating in America and also in Europe. So we can compare the different frameworks. I was going to say very rapidly that incentives, but having heard what Mr. Potocnik said in the previous panel, or in the second panel, was that also trustability is one thing. I think that triggers something in my mind, because it's not only incentives. Of course, incentives are needed, but to get the trust from the users is very difficult. Because the energy sector, and Mr. Potocnik explained it very well, they are probably not aware of the possibilities, but also somehow fed up with our sector, because it's all about prices going up all the time, or not controlling this. So this is one aspect that I will keep for myself from today. Coming back to the other argument of incentives, we are participating in the 3rd European funded project in a row. In the last 7 years, we have participated in 3 of them, major projects gathering several DSOs, TSOs from more than 10 countries and so on. So our concern is that we have the capabilities, at least most of us have them. I'm talking about smart metering, smart meters, and also the infrastructure required to manage them. We are talking about communications, we are talking about platforms, we are talking about skilled staff. This requires a lot of investment, a lot of innovation, and future applicability of smart grids is that. Smart technologies require this kind of things. But we are still concerned about the response from the users. We see that they are reluctant to participate just because they don't see any benefit on that. So this also brings me back to other panel where Mr. Kostek said that incentives are necessary, are fundamental, but also the way that they are proposed. Of course, flexibility should be a benefit for users. They have to get the right incentives in terms of economical benefits, but also for the DSOs, TSOs, we have to see that there is also an incentive to change the way we are operating. And that's something that it's basic. And just to make an example, in my country, in Spain, we have all smart meters roll out for, I don't know, 5 years now, 6 years now. So to me, smart meters are the first and the basic tool to have this demand response in place, because they allow you to monitor the consumption. Also, the customer can monitor their consumption. This is most important because they can react to they can have the response. But also we need platforms. With the European funding project, we learned that we can develop this kind of platforms harmonized across Europe. That's very important because also the service providers will require to do businesses in several countries with not additional cost. That's a very relevant thing too. But in Spain we have this situation, but we don't have the regulatory framework in place. We cannot provide flexibility from users as the DSO. So we have to wait, and then I understand the idea of the proposal of the regulators that we have to try to avoid too many investments. But the real situation is that yesterday in Spain we published the capacity maps for demand, following the the mandate of the electricity market electricity market reform. And yesterday we published it, and the main conclusion was that 83% of the nodes are already collapsed. There are not additional capacity. We cannot connect more demand. We had already the generation capacity maps, but in the demand, in a context of increasing electrification, how we can explain that we cannot connect more renewables, more demand. And also we cannot manage our grids with flexibility because there is not the right framework. So that's a big problem. To brief on that, my advice will be try to speed up the regulatory framework at national level and try to do it in a way that we can get a massive response from the customers, from the users. Not only specific users, the big ones, but also the households, the average user that can also be, all in all, they can make a big difference in the way we are managing our grids. Thank you.
Thank you. I try to speed up because we are running out of time, but never mind. As we heard about new smart substations and OLTC transformers and IVRs, and I could say for minutes on one side, and on the other side, if I order from Temu a laser pointer, I will get a sensor for free. So, Jennifer, what is your answer for that phenomenon that from one side there are so many new technologies which has to be handled somehow by the system operators, and how not to stuck into the too much data, and to convince a CFO that investment into observability, it's a so a different word, is it worth to it from business point of view?
The question is more, what is digitalization in the first place, or what kind of data do we want to look at? And digitalization enables us to actually look at data and act on it. So everyone, or most of us, maybe have a smartphone, for example, and they measure their steps, but the question is, what do you do with that number? What does that number tell you? Many people, it confuses many people if you collect too much data, and it's just what you said. So the idea is that first you need to think, what kind of data do you even want to collect? You have to understand the shape of your grid, of your network. And it was nicely said today that the DSO is the most diverse network that we can think of. And the demand of pushing new energy into that distribution network is insane and so much higher than for the transmission networks. So we really need to think, how do we combine that diversity in assets with that demand of data-driven actions, while we have never collected data before. So before we were completely blind, and now we need to collect data and act based on it. So first we need to standardize. We need to make sure that, especially if you want common interest and if you want EU-wide benefit from this, we need to standardize what kind of data are we interested in and what are the main things we want to look at. And this is on a small scale what we do in Bavaria and southern Germany now, that we first wanted to see something at all. So in the first stage, we installed quite a few digital substations, and we also have so-called retrofit kits that we can install in existing stations where we can collect all kinds of data from voltage to currents and so on. And based on that, because we didn't want to put a whole new program into this, we just wanted to go along with the flow and see what we can install, we install. So a new station is always digital. And older stations, if we do a cycle of service, then we also introduce this retrofit kit, for example. And based on that, we can see locally what is happening locally at that specific node. And that is very valuable, for example, for the service technician to look at. Not for the system operators yet, but for example, for the service technician. Or then when you start planning a new area, where you say, okay, there's a new industry partner coming in, and you want to plan, okay, how do I shape that network? Then you can look, is there data available? Can I already see what is the average load on that substation currently? How do I have to extend that network? Then I can, in a smart way, extend that network, and not just based on these analog meters that you maybe know from these transformer stations, which is like, I don't know, 19th century technology. So this is like a next step. And then only much later, if we have enough data that we can collect in, for example, these hubs, and where we can then bring in also data engineers to help us looking at that data, only then we can understand what kind of information can we get out of that. And that information we need to process and to make available in a comprehensible format to the systems operator. So the systems operator doesn't care about the jitters and all the information and all the timelines of all the different parameters. That would be way too much information, as you said. But it's much more interesting to get the key answers to his questions. So the question is, do I have to act on it or not? So there's no use of collecting data just for the beauty of it, but you only want to collect and visualize whatever you can act on.
Thank you. So we have all the possible new technologies. We decided how to handle the barriers from regulatory point of view, how to roll out, and we have all the information about that. So we are done on 24 degree on normal temperature with a normal three-phase operation, sunshine and everything else. But what happens if there is a tornado in Czechia, or there is a hyperstorm, or anything else? So we used to that everything works on the proper level, but the whole area around us decided to change. How is it possible to keep up with that kind of change and yeah, we should say the climate consideration? Frank, what's your opinion?
Thank you for the question and for the invitation. I recently read in a study from Swiss Re, the big reassurer in Switzerland, that 1 out of 3 of power outages in the USA are related to extreme weather. And then the last 12 years, this frequency, the moving average of those specific events, outages, is rising. So the crisis is upon us, whether we choose to or not. And so obviously that means that weather data is very important. And I believe that meteorologists, technology providers and operators have to work closely together on doing 2 things. One thing is to get better weather, improve this weather data. So there's an example for that applied to the technology that we are developing, dynamic line rating. We have a weather specialist in our company who's working on microscaling. So taking the weather mesoscale weather models that are typically used for the weather forecast, they are 5 by 5 square, a square of 5 by 5 kilometers, and we are refining this based on the hills, valleys, forestation, so to make this more accurate, because we'd like to have specific weather data for every span. So we want to be more specific than the 5 by 5. There are other things that can be done, ensemble forecast and things like that, to improve the weather. The other thing is to use this weather better. And here it's important to say that however we can improve the accuracy of weather, and particularly forecast going further in time, we all know that the uncertainty is never zero. There is always an uncertainty related to it. And there it is then important how to deal with the uncertainty. And actually it means that you have to start to think of these parameters like a rating in a more probabilistic fashion, because if you are taking the uncertainty of your weather input into account, then the parameter that you're going to use is also a probability distribution. And so you'll have to make some decision cutoff point to make this into a thing that you can use in operations. And there will not be an international rule that says you have to use a 90% or a 95% confidence bound, because it's too specific. So this is something that you take the local situation into account and the local understanding of the operation that makes that you can do this translation from a probabilistic space to operations. And then when you combine that, you can actually, and I'll illustrate it again with DLR, or let's say dynamic transformer rating, that would be the same thing. You can do two things at the same time. You can increase the average efficiency of the assets taken throughout the year, because we know that on average, with the average weather, the dynamic rating is higher than the static. And so you exploit it and you have higher efficiency. But the days that you don't have it, then you take the consequences and simply, and if that is slightly below static, then you do that. And by that, you increase the resilience. So you do those two things together. And it's really a management decision how to make this trade-off with the risk appetite and all the factors that are involved, going from market participation to planning to security analysis and finally operations.
Thank you, Frank. I always tell my students at the university that there are no good technology or bad technology. You can utilize something on a good way or you can waste it. I strongly believe that I'm much more closer how to use it on a good way based on your conversation. Thank you very much for accepting the conversation and your time and energy. Thank you.